Welcome everyone to my LeetCode weekly contest 416 live stream. If you're here for solutions, jump ahead to 90 minutes in or use the timestamps in the video description. In a few minutes, we'll be doing the contest live and answering questions in the chat. We'll be giving hints, so come join us every weekend for the contest. No code will ever be shared, no answers will ever be shared while the contest is running, but immediately after it ends, we'll go through our solutions for all 4 problems. So if you enjoy LeetCode content, check out the rest of my channel. I have videos on different problems as well as the hardest question 4s of previous contests. And as usual, like and subscribe to stay up to date on new videos. I am streaming from an undisclosed location, somewhere else. I'm not at home, which means my usual gear. I don't have my usual setup. And that means the sound might be a little bit spotty. But we'll see how it goes. So this contest is about to start. We're registered for contest. Let me see who's around. We're still waiting. I see 5 people. Namho Koi, welcome. Welcome to the channel. We'll be starting in about a minute. Hopefully LeetCode doesn't have the same sort of server problems they've had a couple months ago. I think it's gotten better since I strongly suspect that somebody was DDoSing them before, but who knows. Last week was a pretty hard contest. Hopefully this week will be better. But the nice thing about hard contests is that everybody has a low score. So, it sort of all works out. As usual, remember that reminder that I stream on a different I code on a different window than the one I'm sharing. So if you don't see anything on my screen, that doesn't mean I'm not doing anything. It just means that I'm working on my actual solutions. I don't share code during the contest, and you shouldn't also. So Erin 30 Jaeger. Hi, watching after a long time. Welcome back. Alright, we're good to go. Good luck everybody. Hopefully today's contest will be easier. It's supposed to be easier based on the score points. So good luck to everyone. It's not loading for me. Yeah, well, usual start of contest blues. Okay. Oh, it's really not loading for me. Okay, there we go. You're given an array of strings message, an array of strings span words. An array of words is considered spam if there are at least 2 words in that match exactly any word in banned words. Okay, this is not super clear. If there are at least 2 words in it that match any words in banned words. Okay, so you can have 1 word in banned words that match twice. It sounds like you can have 1 word in banned words that match twice. That's how I read the question. Good luck everybody. Hopefully my interpretation is correct. Please don't be wrong, please. Oh snap. I hope I'm not reading the question wrong. That'd be pretty sad. Oh, I cannot even submit. Today's contest is very slow. Hopefully it gets better for all of you. I see 9 people in the chat. Welcome to the channel. If you're new to the channel, I don't show answers on screen. Hopefully this doesn't automatically display answers. But after the contest ends, we'll go through all the questions. If you have questions about the questions, write in the chat and I'll try to help. So once again, if you have questions, let me ask in the chat and let me know. I will try to help. The chat is very quiet tonight. Which might mean good things, but also might mean bad things. So we'll see. Hopefully it's only good things. What? Hey, yeah. Hey, Rohan Sharma, welcome. Sorry, I've just been working on my own problem set, so I've not been speaking. If you have questions, let me know. Question one is kind of funny. Question one, I actually got a TLE, and I don't know whether it's because I'm using Python. Um, yeah, I got a TLE, even though I'm pretty sure I'm using the best possible solution already. Interesting. Yeah, I wonder why. Hmm. Maybe I'm not. Maybe I'm not doing the best possible solution. Yeah, yeah. I wonder, yeah, I don't know. If people have questions, ask. Yeah, I don't know. I think question one is kind of strange. I'm already, yeah. Let's see if I can do something better. Find if exists. Huh. Message. Can anyone give hints for second one? Sure. I'll try to give you a hint. Yeah, I'm also working on the second one. So the way my strategy is I'm going to approximate how long it takes first. So I'm going to count how many times. Yeah, I'm going to first figure out how much progress I can make in 1 second, and this would come from 1 over all the worker times, and then I multiply. How do I say? Yeah. Well, short answer, I'm also trying to figure out right now. So the way I'm doing it is I have progress per second, and this gives me 2.5 work per second. So this is, and then I take the mountain height. Divide by this. And this will give me the minimum number of seconds. But this is approximate because you don't actually do this much work. If this is a very large number, obviously you'll not be able to compensate. So I basically round down, and then I try to see what's the best way to accomplish. Yeah, but I'm gonna start with this, and this will help me sort of round down, because if I do the simulation, if I just do the simulation, it's going to take a long time. Yeah, so this is my strategy. The other strategy is to find the smallest common multiple of the workers. Yeah, I'm still working on this. Sure, I can explain the question. So let's see. Minimum number of seconds to make mountain height 0. You're given the mountain height, denoting the height of a mountain. You're given an array of worker times representing the work time of workers in seconds. The workers work simultaneously to reduce the height of the mountain. So for instance, to reduce the mountains by height, it takes this times this plus worker times 2 times x seconds. Yeah, it takes. Okay, let's see if I explain this correctly. Okay, so mountain height is this, right? Mountain height, right, is this, right? This is basically how long it takes. Uh, okay, hold on. I gotta reread this because, yeah, I gotta reread this. I gotta reread this because I don't think I read it correctly the first time. So mountain height, reduce the mountain height by x6 plus worker x time times 2 plus worker x time times x seconds. Yeah. Oh, so I actually got it wrong the first time. So it takes worker times I plus worker times 2 seconds and so on. So the workers actually, oh, interesting. So the workers, actually take a long time. So worker 0 take 2 seconds to reduce the mountain height by 1. Worker 1 takes 1 second to reduce the mountain height by 1. And then 1 times 2, which is 2 seconds, to reduce the mountain height by 2. And then worker 3 takes 1 second, or worker 2 takes 1 second to reduce the mountain height by 1. And then they add up to 4. Jesus, this question is trickier than I thought. Okay, so basically worker 1 takes 2 seconds to reduce by 1. Worker 0 takes 2 seconds to reduce by 1. Worker 1 takes 1 second to reduce by 1 and 2 seconds. So reason why worker 1 takes 3 seconds is that the first piece of work you take, the first work that you do takes this number of seconds. The next work you do takes this number of seconds times 2. So it takes more and more time for each piece of work, for each piece of the puzzle. And for instance, this one, the worker times are 3, 2, and 2. So worker 0 takes 1 second to reduce. Oh, it takes 3 seconds to reduce the mountain height by 1. It takes 6 seconds to reduce the mountain height by 2. Worker 1 takes 2 seconds to reduce the mountain height by 1. They take 4 seconds to reduce the mountain height by 2. Worker 2 takes the same thing. As worker 1. So basically, Oh, basically the cost doubles each time. The cost doubles each time for the workers. And then worker 4 or worker 3, 4 seconds, it takes 8 seconds. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The minimum time needed is so this does 10 pieces of work. The maximum time needed is 12 because this worker 1 and worker 2 takes 12 seconds to complete all their work. Yeah, so basically you distribute the work among the 4 workers. You have to distribute the work among the 4 workers correctly. You have to distribute the work among the 4 workers so that they'll finish at around the same time. Because if one finish much faster than the others. Binary search? I don't know. This is a good question. I'm not super sure yet. I'll think about it a little bit more. Yeah, I don't know if a binary search will work. I think it's mainly about distributing the work to the 4 workers. But the workers, there's a lot of workers. Yeah, I don't know what this is. Yeah, I don't know. I might skip this question. I'm going to skip it. I don't know what the solution is. Let me go look at question 3 first. You're given 2 strings, word 1 and word 2. Yeah, I don't know if binary search is the... Yeah, I'm gonna skip this question 2. Let's look at question 3 and what it is. Maybe we get lucky with question 3. You're given two strings, word 1 and word 2. A string X is called valid if it can be arranged to have word 2 as a prefix. Total number of valid substrings of word 1. Okay. So, valid substrings of word 1. So let's say BCCA, and then word 2 is ABC. Oh, so basically this just means all the strings and just confirm substrings is a contiguous non-empty sequence of characters within a string. Oh, okay. So basically, the string it says all substrings that contain word 2 or the letters of word 2. Okay, I think this seems not too hard. So let's say word 1 is BCCA. This seems easier than question 2 actually, to me. And then word 2 is ABC. You need all 4 because you need the B and you need the A. You need the B and you need the A. And then for ABC, if the word is ABC, then you can have this, you can have this, you can have this, you can have this. Basically, any substring here will work. You can have this, you can have this. Yeah. So basically, the thing is, you need substrings of word 1 that contain letters of word 2. So all the substrings of word 1 that contains all the letters of word 2 will be valid. And you need to find this in a fast way. I think that should be quite straightforward, I think. And just for fun, I'm going to look at the question 4 also. I want to see if, because question 4 and question 3 have the same name, I want to see if question 3 and 4 are the same. Okay, so question 4 requires a linear runtime complexity. Yep, I think I know how to do it. I think so. I'm not sure. I'm gonna try it out. I'm gonna skip question 2 and do question 3 and 4. I think question 3 and 4 is easier. Okay. Yeah, question 3 is easier. Hmm. Okay, let me see. Question 3. Probably some kind of sliding window is my guess. Probably kind of, I think it's stuff from left and right set number. Use binary search from the second one. Huh, interesting. Yeah, thanks Shift Kurana. Yeah, thanks for the help. Um, I think folks can take a look at it and see if it's helpful. Just make sure don't paste any code here, because if you paste code, it gets copied and then we get into all kinds of trouble. Yeah. Valid substrings word 1. So the interesting thing about question 3, so one interesting thing about question 3 that I'm seeing is that words 2 is very large. Words 2 is 10 to power 4. Words 2 the length is 10 to power 4. So if you do a sliding window, it will be linear in the time of word 1 dot length, but it will how do I say this? It's going to be depend on the length of words too also. Uh, well, can you write the code? No. So, please don't share code here on this channel. Sharing code in LeetCode contest is very dangerous because, you know, if you get caught, then the whole thing comes down. We all get in trouble. Please don't share the code. Sorry, Ahis Moharana. If you, I'm going to have to remove this message. I'm so sorry. If you want to have the answer, just wait until the end of the contest, and then we'll go through all the four answers for all four questions. So sorry about that, Ahis Mohana. Yeah, I have to remove your message. Yeah, sorry about that, Ashish Moharana. But you can use the hint that is given. You can use the hint that's given by Shiv Kurana. But just don't share code. But you know, at the end of the contest, we will talk about all. I will share the code, and when I have time tomorrow, I'm going to write up the code nicely and then upload to GitHub, so you can view that also. I'm working on question 3. I yeah, question 3 is a yeah. Thanks again, Ashish Moharana. Question 3 is should be some kind of sliding window. I think. Uh, I hope you guys are doing better than me. Let's see. Well, not valid. I have some bug here. Okay. L equals 0, R equals 0. Why is R equals 0? Finding some bug here. R equals 0. Why is this wrong? Interesting. Yeah. Okay. Okay. Huh. Trying to. There's so question three. I'm pretty sure is slightly in though, but I've had a lot of bugs, and I'm not able to solve the bugs. Mm. BCCA. Okay. Oh boy, this contest will be not good for me. Okay, ABC 0123. Okay. Okay, if not valid this, then add 1 to it. R3. Okay. Okay, run. Oh crap. Ah, let me see if there's any question. How to implement check on mid in second one using binary search. So for second one, probably what you need to do is you need to calculate. Yeah, you actually have to calculate this. So for instance, let me try it. I'll open a new screen. So for instance, at time t, you calculate how much work was done. So worker 0 would have done yeah, basically you can calculate how much work it was done. It was like n square, right? So worker would have done k, 2k, 4k, no, 3k, all the way. You find out which one of these is up to, must be smaller than t. So basically, where k is the amount of work that worker 1 does. So where k equals to times I. So the amount of time it takes for worker 0, for worker I to produce, some unit of work is equals to this. This is a arithmetic progression, like n minus 1 over 2, n plus 1 over 2. So you calculate the arithmetic progression. Yeah, actually I don't know. Well, actually it's a good question. How much work it takes? I guess you have to reverse this somehow. I haven't done question 2 yet. Question 2 seems really difficult. So I haven't done question 2 yet. So the basic idea is you have to calculate how much work each worker is able to do at time t. And you basically calculate the arithmetic progression and then you divide. Yeah, I think that's the best explanation I have. I'm still working on question 3. I'm taking a long time on question 3. I've sort of a little bit given up on question 2. I'll come back to question 2 when I'm done with question 3. String index out range. Alright. Let's hope this works. Fingers crossed. Wrong answer. Damn it. Ah, shit, off by 1. Really? Damn it. Ah. Done. Second, third Z function or something like that. I don't know about Z function. I use a sliding window. I use a sliding window essentially. Yeah, so you want to count, you look at word 1 and you want to count how many substrings of word 1 contains all the letters of word 2. So this is test case in second. Yeah, I don't know. What is a wrong answer? Yeah, it depends on what your wrong answer is. You're very close. It's probably some kind of off by one. It's probably some kind of off by one answer. It's the last few are always very annoying because they don't show you what the answer is. They don't show you what to expect and what the actual test case is. So it gets like extra annoying. R equals length of word 1 break. Okay, let's see if I'm trying my luck with question 3 and output limit exceeded. Ah, fuck. Oh, at last, question 3 accepted. Ah. So my question 3 is kind of scuffed. But I wonder if I just put in question 4 and it'll work. I'm pretty sure it doesn't work. Like 90% sure it doesn't work, but you know, can't hurt to try. Time limit exceeded for question. Oh my god! I'm so close. What the heck? Ah, I was only able to solve one. It's okay. This is difficult. The question 2, question 3 are all super difficult. Ah, freaks of previous. Larger. Okay, I think Ah, damn it, it's wrong. Okay, sorry if I'm quiet. I'm working on question 4. Uh, damn it. I think I'm close. I think I'm close for question 4 because question 4 and 3 are actually the same. So you can do question 3, maybe question 4 will be easy. I hope. But maybe I'm wrong. Ah. Ah, 7 more minutes. Why is r equals to 6? Damn it. Ah, shit. I'm very close to this, but I think I have to give up. Damn it. Hmm. Hmm. I think I'm going to give up on question 4. I'm only also able to solve 2 questions. So if you're not very successful, don't feel too bad. The contest is about to end. I want to take this chance to ask if you enjoyed this contest, if you like my channel, please help by liking and subscribing. You can just click the like button on the stream right now. If you're not subscribed and you enjoy what I do, subscribe so you can find out when's the next time I'll be doing this live on stream. I try to push out videos when I can. Been pretty erratic about it. But if you subscribe, then you know when the new videos are coming out. And if you can't, do comment on the video once it's uploaded later today. That helps me out a lot. Equals to breathe. Yeah, I need to do a better job. My code is very messy for question 4. Question 4 I actually managed to get. Yeah, question 4 actually managed to get almost all the. Yeah, question 4, when I just copy paste question solution to question 3 into question 4, I got almost all the answers except the last one was time limit exceeded. And I'm pretty sure the reason for that is, yeah, I got 758 out of 759. I'm pretty sure the reason for that is that I didn't do the. There's one small part that I'm not doing correctly. Okay, alright. Well, it looks like the contest is about to end. I hope you guys did better than me. I only got 2 questions this time round. Comments in the chat to let me know Is it a DP question? Which one is a DP question? You mean 4 or 3? So I'm pretty sure it's a sliding window question. You can use DP also. Yeah, you can use DP also. I just use sliding window. The sliding window is, I guess window is equivalent of DP, right? It's kind of like the simplified version of DP. If you can do sliding window, you can do DP. DP is the like more powerful but slower. Yeah, very nice. You did sliding window. Good job. Yeah, 3 and 4 should be both sliding window. Permutation, I don't know. I don't think it's permutation. It's not permutation because you need to a substring. If you're looking for what do you call it? Like subarray. Subarray is like, you know, you find any combination, then it should be permutation. But because you're looking for substring, you're looking for continuous string, contiguous string. I don't think it's permutation. Okay, cool. Let me just refresh this a little bit. This is going to be a shitty contest for me. I'm pretty close to getting question 4. I had a bunch of bugs. If I didn't have the bugs, I would be able to get it. So I'm a little bit upset, but you know, life goes on. Alright, once again, if you haven't liked and subscribed to the channel, it will help me a lot. I will be very grateful if you can just click the like button on the screen right now. I'm going to take one sip of water and then I'm going to go through the answer for all 4 questions. I'll be right back. Don't go away. Okay, cool. Oh, 2 hashes of 26 and check if the hash is equivalent. Oh, that's a pretty smart way of doing it. That's a smart way of doing it. I didn't do it that way. I just check each letter individually, and I just check each letter individually, and it turns out it's slower. Yeah, but I think the basic idea should be the same. All right, let me get going because it's pretty late. Okay, let me get going because it's kind of late. All right, as usual, this is my spiel for the YouTube algorithm. We are discussing solutions for LeetCode Weekly Contest 416. Jump to specific questions using timestamps in the video description. Please check out the rest of my channel if you enjoy LeetCode contents. Like and subscribe to stay up to date on new videos. Alright, I'm just going to go through all 4 questions as quickly as I can. Starting the report spam message. Question 1. Report spam message. You are given an array of strings message and an array of strings banned words. And an array of words is considered spam if there are at least 2 words in it that match exactly any word in banned words. Return true if the array message is spam and false otherwise. So this question is not super difficult. Let me just see if I can get it to appear. This question is not super difficult. The main thing is you have a bunch of words and you have banned words. And the idea is you want to go through each of the banned words against the messages. And you want to check each of the banned words if they appear. If there are at least two words, if there are at least two words in messages that appear in the banned word list, then this message is considered spam. So the basic idea is pretty straightforward. You have a bunch of banned words. Because the banned words can have duplicate, you can use a set. Banned words can have duplicates. So for instance, you can say, whoa, hello, 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 hello. The number of times a word appears in banned words will not affect the outcome. The number of times a word appears in message will affect the outcome. So banned words, the best way to do this is you just remove all the duplicates, and you do that using set. And then the next thing you want to do is, for each word in banned words, you want to see if it appears in message. And you can do it the other way. You can also do it for each word in message appear in banned words. So it's the same way. I did it this way. Make sure you just use a binary search. And you just check. You find the index. If index is found, if it's not found, then continue. If it's found, then check if the next one, the index plus 1, is true. Then you can return true right away. If not, then you add it to count. So this is if the banned word appears once. This is if it appears twice. Yeah, this is fairly straightforward. The main thing to know is you need some kind of binary search. You can do it this way. You can flip it around. You can also turn you can also do message and then put banned words in a set, and that will work also. So it's basically up to you. Question 2. Okay, so question 2, I wasn't able to get it. I wasn't actually able to get question 2. I'll just explain the question first. Minimum number of seconds to make mountain height 0. You're given an integer mountain height denoting the height of a mountain. You're also given an integer array worker times representing the work time of the workers in seconds. The workers work simultaneously to reduce the height of the mountain. For instance, worker I, to decrease the mountain height by x, it takes worker I times worker times I times 2 all the way to worker times I times x. So to decrease the height of the mountain by 1, it takes this number of seconds. To 2, it takes this number of seconds, and so on. So this is very weird. This is like this is a weird way of saying. Basically, all this is saying is that the time taken by workers is not linear. So for instance, worker 0 here, in order to reduce the mountain height by 1, it takes 2 units of time. In order to reduce the mountain height by 2, it's going to take 4 units here. In order to reduce the mountain height by 3, it takes 6 units here. It takes 6 units here. So the mountain height is not really linear. The time it takes to reduce the mountain height is not. The time it takes to reduce the mountain height is not going to be linear. Sorry, my voice is going down because I realized that the place I am, the echo is very loud, so I'm worried that I'm waking other people in the room. I'm in an Airbnb right now. And then worker 2 is the same thing. It takes 1 unit time, 2 unit time, 3 unit times, and 4 unit times. So the main thing to Yeah, the main thing to note here is that the strategy that was given I think by def is to use by def is actually to use a binary search. So you must be able to calculate how long based on time t, how long each worker is able to work. So for instance, at time t, worker 0 will be able to do, let's say time equals t equals to 10. Worker 0 will be able to do 4 units, 2 units of work. And then worker 2 and 3 will be able to do 4 units of work. So if you're able to calculate how much time it takes for each yeah, sorry, I'm very distracted because I'm in a shared Airbnb and I think that I may have woken somebody up. This will allow you to figure out the midpoint, and then you just do a binary search over from t equals 0 to t equals a very large number, and then at each moment you calculate how much work was done. If it's greater, then you increase t. If it's smaller, increase t, and this will should get you to the right answer. Okay, so question 3, minimum number of, so count substrings. Question 3, I'm going to explain question 3 and 4 at the same time because I did a sliding window for question 3 and question 4 and they should work the same way. So question 3 is count substrings that can be rearranged to contain a string 1. You're given two strings, word 1 and word 2. A string X is called valid if it can be rearranged to have word 2 as a prefix. Return the total number of valid substrings of word 1. So the way to understand this is that basically any substring is valid if it contains all the letters of word 2. If if it contains all the letters of word 2, then the string will be considered valid. String to consider valid. Sorry, I'm very distracted because I hear a noise coming from the rest of my Airbnb, and I think I may have woken up the owners of the host of the house, in which case I might get kicked out. I'll be in big trouble. Yeah, they didn't text me, so I think it should be fine. Okay, so two strings. So the basic idea is you need to count how many substrings of W1 contain all the letters of W2. So this is basically a sliding window problem, right? We all know this. You have a left pointer and a right pointer, and then at each point, or you can also use like dynamic programming, doesn't matter. At each point, you want to calculate what are the words within the window. So for instance, when the left is here, how far can you move the right pointer? What is the furthest you can, when left is at 0, what's the furthest you can move the right pointer such that you can contain all the words of A? So when when left is at B, when it's 0, the right pointer is 0, 1, 2, 3. The right pointer must be all the way at the end, B, C, C, A. Only then will it contain all three letters A, B, and C. So the count, the number of valid substrings, will be the length minus 3, which is 1. For when the left pointer is at index 1, the right pointer, no matter how far it moves, will never be able to contain all three letters of A, B, and C. So this is infinity. So this is 0, 0, 0. So the total is going to be 1. Let's try with a different example. So let's try with a different example. Let's say your word is A, B, C, A, B, C. When your left pointer is at 0, in order to contain all three words of A, B, C, you have to be 0, 1, 2, 3. So your right pointer has to be at 2. And since the length is 6, your count is equal to 6 minus 2, which is 4. What this means is there are basically 4 substrings starting at the index 0 that contain A, B, C. So A, B, C, A, B, C, A, A, B, C, B, A, B, C, B, C, 4. So when your left pointer is at 1, your right pointer is going to be at 1, 2, 3, 3, and that's basically 2 substrings. Yeah, 3 substrings. When your left pointer is at C, your right pointer is going to be C, A, B. Your right pointer reaches here, it contains all 3 strings. So this is 4. And your count is equal to 2, is 6 minus 4 gives you 2. What this means again is that starting from this index, you have C, you have CA, sorry, C is not valid, you have CAB, CAB, C, 2 substrings which contain A, B, and C. This is what this means. And these guys are all infinite, because if left pointer is here, wherever you move your right pointer, it will never be able to contain all. Oh, actually this is not infinite, sorry, my bad. This is 5 and this is 1. These two are infinite, they are 0. So basically you if you sum this up, you'll get your count. So this is the sliding window solution. This should work for both 3 and 4. The only tricky part for 4 is that you have to be very efficient about where you move your right pointer. So the way I move my right pointer is that when I moved away from an A, I want to move my right pointer until I find the next A. If let's say I'm ABC, right? If I move my left pointer from index 0 to index 1, I lose one A. So I need to move my right pointer until I get the next A. So the way to keep track of how many is you need some kind of window. B equals 1, C equals 1, that keeps a count of how many numbers you've seen in each, how many frequency of the occurrences of each letters that you have seen. So somebody in the chat, AJ, use a hash table. Yeah, and he was successful about it. I didn't use a hash table. what I did is, if I have an A, I keep moving until I find my next A. So I don't have to compare all the letters in the window. In question 3, I compared all the letters in the window every single time, and it works. In question 4, I moved to the next A. And because I have a bug, it didn't manage to work. But AJ's solution is actually more clever than mine. So he will compare all the occurrence of every letter, but he does a hash table. And this way it's going to be much faster. Okay, I hope this was helpful. This concludes the end of the live stream. I hope this was helpful to people. As usual, comments, like and subscribe. Comment in the video about how you did, because I'm always curious to find out. If there are no questions, then I'm going to head out now. Thanks a lot. Goodbye. See you next week.